Hello class, this is the part 2 of our lecture in acids and bases which involves a problem solving ng ating problems dito sa lecture 1. Okay. Now for the first problem, which is an example of 10-1, this is from the book of Wittens, Davis, and Peck. I think that's 11th edition. Okay. Now let's answer this in the part of Bronsted and Dory Q. Write the equation for the ionization of nitric acid in water. That is for letter A. Letter B here. Okay, let's solve the problem. Okay, here, write the equation for the ionization of nitric acid in water. So, sa letter A natin daw is the nitric acid is ionized in water. Okay? Kasi nga, di ba, we have water, nilagay ninyo yung nitric acid here. Okay. Ngayon, ano kaya yung nitric acid natin? Is it an acid or an base? Now, based from the list, from here, sa ating acids and base strength na nandito, it is an acid. And it is obvious naman, based from the name itself, it is an acid. Okay, now, kung natin dito, it is an acid, ayan. And therefore, water will be the base. And then, proton donor, okay, the product, mawawalan siya ng, mawawalan siya ng hydrogen, which is hydrogen has a charge of positive 1. And then this one here is neutral. So neutral, so tinanggal mo hydrogen, so that's charge of positive 1, minus 1, and that is negative 1, kung saan siya magka-charge ng nitrate ion. And by the ways, memorize nyo naman yung mga charges ng natin, ng mga atom, ng mga ions and anions natin dun sa ating periodic table. Nakikita niya. Okay. Then the base, okay, since yung proton daw natin ay tinransfer natin dito, so nagdagdag ka ng positive BD1 charge. So it is a hydronium ion. Ayan. Now from letter B, identify the conjugate acid-base pairs in the equation for part A. Okay. Di ba yung acid will form a conjugate base? Tama. So this one here is the conjugate base. And then the water, the base, will form its product into a conjugate acid. So siya ay magiging conjugate acid. Ayan. So the pair of this is the nitric acid and this one here. These are the conjugate acid-base pair of our natin. So, shortcut ko na lang. Ayan. Conjugate acid and teka. Tama. Conjugate acid and base pairs. The conjugate acid is yung ating hydronium ion and water. While the conjugate base acid naman natin dito is yung conjugate base is yung ating nitrate ion here and nitric acid natin. So letter C, what is, ayan, so we're done with letter B. So letter C, what is the conjugate base of H3PO4? Ayan, no? H3PO4 or phosphoric acid natin. Ayan, H3PO4, phosphoric acid. Okay? Sasagutan lang natin di letter C here. Ayan, letter C. Letter C. Ayan. H3PO4, the conjugate base. So, ano daw yung kanyang conjugate base? Okay? Okay, phosphoric acid. Ayan, will mix in water. So, since it is an acid, babawasan mo siya ng ano daw. This is an acid and this is an base. Kasi from the name itself, phosphoric acid. So, H2PO4 negative plus hydronium ion. Kasi nga, acid, proton donor, proton acceptor, and this one here is the conjugate base. And this one here is the conjugate acid. So therefore, the conjugate base of our H3PO4 phosphoric acid is H2PO4, 2 negative. Or para mas madali, you don't need to write this equation. Bawasan mo lang ito ng hydrogen. Ayan, you will generate a conjugate base. Okay? So letter D naman na tayo. What is our letter D? What is the conjugate acid of sulfate solution? Of sulfate ion. Okay. So, conjugate acid naman daw ng ating sulfate ion here. What is the conjugate acid? Okay, para mas madali, here, dagdagan mo lang siya ng hydrogen. Kasi nga, conjugate acid. So, therefore, HSO4 negative. Yan agad yung sagot. And if you wish to write the equation para mas maintindihan ninyo, ayan, sulfate, nilagay ninyo sa water, nag-form, this one is the acid, and this one is the base. Ano man yan, obvious naman yan kasi since this one, the sulfate ion does not contain a ionizable hydrogen ion. Tama? So therefore, proton transfer here, ayan, HSO4 negative plus OH. Ayan, the conjugate acid, this one here is the conjugate base ng water natin. So that's how you answer the example 10-2 for our part 1. So take screenshot guys kung kailangan nyo pa screenshots. So ayan. Here. Okay, let's natin. Let's have a new presentation here. And let's go on to the calculations part. These are the formulas. Ayan. Example 10-1. 18-1. Calculate the concentration, the molar concentration of barium and hydroxide ions in a 0.030 barium hydroxide. So, ano daw ang concentration ng barium? Okay. Ano daw ang concentration ng barium? And ano yung concentration ng ating hydroxide ions here? Okay. So, the barium hydroxide here, okay, the barium hydroxide daw is dissolved in water. Now, we all know that the barium hydroxide is a strong base. So, magkaroon siya ng complete ionization. Teka, barium. Teka. Let's bring natin barium hydroxide. Ayan. So, ba't hindi po molecular formula ang nakasulat dito? Okay? You reach this point, so dapat alam nyo na yung molecular formula na yan kasi napag-aralan nyo yan nung high school. How to write a chemical formula based from the name of our inorganic substance. So, barium hydroxide na dissolved sa water, okay, magpo-form ng complete ionization with barium ions plus hydroxide ions. Okay? But the reaction is not balanced because, ayan no, meron tayo OH, 2 OH, pero dito isa lang. So, lalagyan mo siya ng 2 dito. Ayan. So, ano daw yung concentration nila? Okay. So, meron tayo dito na 0.030 molar. So, kapag na-dissolve yung complete ionization, it will yield a 0.030 molar. While this one here, since 2 times siya, 2 times 0.030 molar equals to 0.060 molar. So, therefore, the concentration of our barium ion is 0.030 molar, while the concentration of our hydroxide ion is 0.060 molar. So that's the answer for sample problem 18-1 based from the book of Witten's, Davies, and Fick. Okay, take screenshot so we can proceed on our next problem. Okay. Sample problem, okay, 18-2. Calculation of concentrations. Ayan. Calculation of concentrations here. Ayan. Calculate the concentration of hydronium ion and hydroxide ion in a 0.05 molar of nitric acid solution. Okay. Nitric acid solution, okay. We all know this is an acid, this is a strong acid. When dissolved in water, it will yield a hydronium ion plus nitrate ion. No, di ba kanina, sinabi natin kanina, kapag strong acid, kung ano ang concentration ng acid, yun na rin ang concentration ng ating hydronium ion. And ano daw yung concentration ng ating nitric acid? That is 0.05 molar. So yun na agad yung sagot natin dito. But what about the hydroxide ion? Okay, ano kaya yung concentration niya? Gagamitin natin yung formula na nandito sa ating slide na to. Ayan, no? Hydroxide ion times the hydronium ion is equals to 1.0 times 10 raised to negative 14. So therefore, gagamitin natin, ayan, hydronium ion times hydroxide ion here is equals to 1.0 times 10 raised to negative 40. Ngayon, ibababa ko to, ayan, to isolate hydroxide ion to form a hydroxide ion here into 1.0 times 10 raised to negative 14 all over the concentration of the hydronium ion, which is 0.05 molar. So substitute the known values times 10 raised to negative 14 all over 0.05 molar. And the concentration of our natin, wala pala akong dalang calcu. Wait lang, guys. Okay, the answer is 2.0 times 10 raised to negative 13 molar for our hydroxide ion. So that's the answer for our example 18-2. Okay. Now take screenshot so we can proceed to the next problem here. For the 18-3, okay. I think you all know how to calculate this one. Alam niyo naman na yan. Just use the negative log hydronium ion sa 0.05 molar using this formula here. So ang answer dito, guys, is just ayan o, negative log times 0.05. Your answer should be pH is equals to, your answer should be, ayan o, pH equals to negative log, ayan nyo lang, 0.05 molar, and you'll have the answer of 1.301. So that's how you answer it. Negative lang lang. Kasi calculate the pH, which the pH is a formula of just a negative log times the hydronium ion. Okay? Ayan. Let's proceed to our next problem here. Example 18-4. Okay, ito naman, napagbaliktad natin to. Wait lang. Okay, dito naman, guys, is the pH of the solution is 3.301. What is the concentration of hydronium ion in this solution? Okay, actually, you don't need to memorize the formula kung alam niyo kung paano mag-derive. Di ba? Ayan o, di ba? pH is equals to negative log of hydronium ion. Di ba? And then get the antilog of this both sides. So what is the antilog? It's the shift log or 10 raised to something here in order to cancel out the log. So the hydronium ion is equals to 10 raised to the negative of the pH, which is nandito rin naman yan sa may formula natin dito. Ayan. So let's get back to the problem. So 10 raised to negative 3.301. Ang sagot natin dito is, ayan o. So the answer is 5.0 times 10 raised to negative 4. That's not 14, that's 4 molar. So that's it. That's how you answer the problem 18-4. Okay, so let's proceed to the next problem. Ayan. So 18-5. Okay. 18-5. Calculate the hydronium ion, the pH, hydroxide ion, concentration, and the pOH of a 0.015 molar of nitric acid solution. So, apat ang ika-calculate dyan. You will use a simultaneous formula here. Okay, siyempre, ang may una natin gibin natin dito is yung hydronium ion, di ba? Kapag strong acid, the concentration of the acid natin is the same as the concentration of the hydronium ion. So, the concentration of our hydronium ion is 0.015 molar. So, check na agad yan. In order to calculate the pH, okay, simple as negative log of the concentration of hydronium ion is equals to negative log of 0.015 is equals to Ayan, no? Na-calculate nyo na. The answer is 1.824. Ayan. So, it's check. What about the POH? Okay, di ba? Sa formula natin na based from this slide, ayan, you all know this naman. You all know this formula. You're very much familiar to this. So, ayan, pH plus POH is equals to 14. So, transpose mo yung pH dito sa may kabila in order to calculate for the POH. So, therefore, 14 minus 1.824 is equals to 0.824. Ayan. The answer is 12.176. So, POH is checked. And then, sa may hydroxide ion. So, how do we calculate for the hydroxide ion? There are two approach na pwede niyong gawin. Pwede niyong gamitin yung POH. Pwede niyong gamitin yung hydronium ion. Now, let's take the approach for the manggagaling sa may hydronium ion natin. Okay? Di ba meron tayong formula na hydronium ion times hydroxide ion is equals to 1.0 times 10 raised to negative 14. And then meron din naman tayo, in order to calculate the hydroxide ion, is just 10 raised to POH based sa ating formula. So ayan, in order to calculate the hydroxide ion is 1.0 times 10 is to negative 14. So ito yung dalawang formula na pwede natin gamitin. Kahit saan naman dyan, pwede magkakatalo nga lang sa may rounding off. Pero kapag hindi niyo ni-round off at in-answer nyo directly yung mga sagot natin, is makakakuha kayo ng exactly the same answer of both approach. So, ganon. Ganon naman talaga ang chemistry, di ba? Maraming solution, pero iisa lang yung sagot. Okay? So, there, we have roadmap, but the destination is always the same, no matter where the paths you go. Okay? So, ikon na natin to. Let's substitute to the approach number 1 natin dito is, ayan, negative 14 times the 0.015 molar. You will have the answer of, ayan, 6.67 times 10 raised to negative 13 molar. And then dito naman, kapag kinon ninyo dito, 10 raised to negative 12.176, ang magiging sagot natin dito is 6.67 din. Pero ang nasa calculator ko is 6.668. Dito kasi 6.666666, ayan. Pero dito 6.668. So pwede natin siya i-round up na 6.67 times 10 raised to negative 13 molar. And don't forget the units, guys, ha. The units for our hydronium ion and hydroxide ion concentration is expressed in molarity. Okay? Molarity, which is moles per liter na pag-aralan ninyo sa inyong solutions. Physical properties of solutions. Okay? So, ayan, may mga sagot natin. Okay? To sum up our discussion here, ayan o. Ayan, so let's check. So, that's how you answer it. Now, for our last problem here, ayan, nasan na siya? Ayan, calculate the pH, the hydronium ion pH, hydroxide concentration, pOH of a 0.015 calcium hydroxide solution. This one is a base, not an acid. So gagayahin nyo lang, ang mangyayari lang dito is makukanin nyo yung twice the concentration of the hydroxide ion. And then kayo nang bahala mag-calculate sa iba. And that will be a part of your learning activity. Okay? So, hindi ko siya sasagutan sa part na ito. Ayaw magsasagot niyan. Okay, next. Ngayon dito, sa may mga naging discussion natin, guys, kung mapapansin ninyo, ang bilis i-calculate ng mga pH natin. It's just a negative log of hydronium ion. Bakit kaya ganun? Kasi nga, ang kina-calculate natin dito is the pH of a weak acid. And weak acid has a complete dissociation. So, paano naman, guys, if kapag weak acid naman, which involves an equilibrium, di ba? It was discussed in the part of our discussion that the concentration of the weak acid, its conjugate base and the hydronium ion exist in one solution. Not purely the conjugate base and the hydronium ion in the solution, because due to the partial dissociation of the weak acid, that give the rise to our equilibrium constant. Now let's calculate here. Calculate the pH of a 0.10 molar formic acid at 25 degrees Celsius, and the acid dissociation constant of the formic acid is 1.8 times 10 raised to negative 4. So how do we calculate this part here? Now, kung siya ay strong acid, di ba? Ayan, no? Kung strong acid siya, ang bilis ng calculation natin, guys, di ba? Ayan, no? It's just a pH is equals to negative log of 0.1 molar. Ayan. So, negative log lang o 0.1 molar. Ayan, may sagot ka na, sir. Sir, ang sagot po ay 1. Dude, ito ay weak acid. Weak acid ito. So, it involves a Ka, acid dissociation constant. So, ang mangyayari dito, magkakaroon tayo ng ICE. But first and foremost, let's write the equation for the ionization of formic acid. So, HCOOH, minix ninyo sa water. Nagkaroon ng equilibrium, so magpo-form ng formate ion as a conjugate base and hydronium ion, which is the acid. Dito manggagaling yung pH natin, okay? So, ICE, initial concentration equilibrium, change in concentration, and equilibrium constant. Napag-aralan nyo yan sa inyong general chemistry ninyo. Okay? So, ano yon? 0.1 molar. 0.1 molar. This one here is 0 because water and the solid are not included in equilibrium solids. And then this one here is 0 kasi hindi pa nagpo-proceed yung reaction natin. Okay? Ngayon dito, ang mangyayari is, since it is a reactant, siya ay minus X. So here is 0 na siya talaga, so it is not included actually in the equation. This one here, formation of product will be plus X. So therefore, 0.1 minus X, this one is X, this one is X. Okay, now dito na papasok yung Ka natin, which is the acid dissociation constant. Now, saan the expression of the equilibrium here, di ba, is product all over reactant. So therefore, for concentration of formate ion times the hydronium ion all over the HCOOH, ayan, na may value na 1.8 times 10 raised to negative 4. Now, substitute the variables here, since formate is equals to X and hydrogen ion is equals to X. So therefore, that will be X times X all over, ayan, no? 0.1 minus X, 0.1 minus X. Ayan. So, ganyan. So, dito, gagamit kayo ng, anong gagamitan dito in order to here dito, gagamit kayo ng use quadratic equation to solve for X. Pero dito, since the value of our equilibrium constant dito, ito ay, ayun, no, sobrang liit niya. Kaya, ang mangyayari dito, magiging negligible yung value ng X na ito, which in turn, ang matitirang value natin dito, mariretain natin dito is 1.8 times 10 raised to negative 4 is equals to X times X all over 0.1. Okay, let's distribute the equation into, ayan, X squared, kasi nga X times X equals X squared equals to 1.8 times 10 raised to negative 4 times 0.1. In order to cancel the squared here, square root both sides. So, mag-yield tayo ng X is equals to square root of 1.8 times 10 raised to negative 4 times 0.1. And the answer in this equation is 4.24 to 3 kasi 6 times 10. Nag-round off na ako ba? Pero hindi. Ayan, 2, 6 times 10 raised to negative 3. Pero guys, actually, ang ruling dito is as much as possible, huwag kayong mag-round off. Kung gumagamit kayo ng scientific calculator, isulat nyo lang na rounded off dito sa papel kasi masyadong mahaba. Pero sa calculator nyo is i-retain nyo siya as is. I-type nyo yung ANS or ANS. Ayan. Okay? So the X. And we all know, okay, pasaali lang yun. We all know that the value of X is equals to the concentration of the formate ion, the concentration of hydronium ion based from this. So therefore, meron tayong value ng concentration ng ating hydronium ion dito. And in order to, ayan, hydronium ion has a concentration of 4.2426, and then the numbers here times 10 raised to negative 3 molar. In order to calculate the pH, ayan, tsaka mo lang siya negative log times the concentration of hydronium ion. Then, ayan, so negative log, the value, which is 4.2426. Then the other values times 10 is to negative 3. And ang sagot natin is negative log. Answer 2.372. So that's the pH. So, dyan nyo pala makakalculate yung pH ng weak acid natin. Hindi yung dito, tignan nyo ang layo ng sagot ko. O, di ba? Negative log 0.1 and voila, may sagot ka ng 1. Pero hindi, weak acid yan. So, dadaan ka sa may proseso. That's how you calculate the pH. Okay? Ayan. Kapag naman base, guys, same process din, but ang value na makuha ninyo is hydroxide ion. So, makapag-yield ka ng POH, yes, let's subtract it by 14, from 14, ayun, mag-yield nyo yung value ng pH if the pH yung hinahanap sa may problem natin. So, that ends our discussion here, guys. Okay, take screenshot here. Take screenshot to take note the solution. Okay, thank you guys for listening, and that ends for our lecture number 1 for the discussion of the basics of acids and bases. Have a great day, guys. I hope you learned something, and goodbye.